Now that we've learned several different methods for solving quadratic equations, let's go ahead and review. Now, in this video, we're going to solve the same problem up to 3 times. So the first equation is x squared plus 8x minus 16 equals 0. So the first way we learn to solve quadratics is by factoring. So to factor, it has to equal 0, which it does. And when we're factoring, the very first step is to look for a GCF. So something that goes into 1, 8, and 16, and there is no GCF. So then after we look for a GCF, we ask ourselves how many terms, and there's 1, 2, 3. So when there's 3 terms, we take A, which is 1, and C, and multiply them together. So that's negative 16. So we have to find what multiplies to negative 16, and it has to add to a positive 8. Okay, so since it has to add to a positive number, we know that the bigger number has to be positive, and we know one of them has to be negative because it has to multiply to a negative. So that's how I know the smaller number is the negative. And then as we try to add these, none of these will multiply to negative 16 and add to 8. So this one is not factorable. So then we have 2 other choices. So that's why we learned all the different methods, because again, not everything can be factored. So now let's go ahead and try completing the square. So with completing the square, there's a couple different ways to do it, but the way that I focused in this class is we want to take the C term, the constant, and move it to the other side. Okay, now notice I left a little gap here, and the reason being is it's not factorable. So I'm moving this number over here because I want to put a new number right here that will make this problem here factorable. So again, as you could see, this is why we learn completing the square, is because the original problem was not factorable, but now we're going to put a number here that will make this here factorable. Not only is it going to be factorable, but it's going to be a perfect square. That's our goal. So to do that, oops, I just realized I had with the 16, 0 plus 16 is 16, so that should be a 16. So to complete the square, we're going to take this 8 and divide it by 2. So we always take the B term, divide it by 2, and then square it. And that is 16. So that is the number that if we add it into the problem here, this is going to be factorable as a perfect square. Now you can't just add a 16 on this side without putting the same amount on this side. So since we entered a new number into the problem, we're going to put a 16 on this side. So I'm going to do 16 plus 16, that is 32. And now the whole point, why did we do this up here, is because now this should be factorable. So what multiplies to 16 and adds to 8? So 4 and 4 multiply to positive 16, and they add to 8. So instead of writing this as x plus 4 and x plus 4, which you can, but the whole point is to be able to write it as a perfect square. So since these are always going to be the same, and they're always going to be the same because of this, then I can write it with an exponent instead. So again, if you show your work over here, this number that's going to go right here is always going to be this number right here before it was squared. Okay, so again, now why did we do this? Because it has this exponent of 2, so why didn't we write it as x plus 4 times x plus 4? We wanted this exponent of 2, so that way then we can square root both sides. And remember, when we enter into a problem with a square root, we need a plus or minus in front of it. So then this and this and the radical is going to go away because this is a 2, and 2 goes into 2. We can write this like this. You don't have to show this. I just want to make sure it's clear why this radical goes away, because we can write radicals with exponents, and that would be 2 over 2, which is just 1. So that's why that exponent and the radical just goes away. So if you want to write it like this to remind yourself that this would make just 1x plus 4. Okay, so now we're going to go ahead and simplify our radical here. So square root of 32, I'm going to go ahead and make a factor tree. So I'm going to pick any two numbers that multiply to 32 that I want, and then I'm going to keep going until they're all prime. Okay, and as we learned in class, we think of this radical as like the jail, and to escape the jail we need 2 of a kind, since it's an even or index of 2. So we're going to have a 2 escape, and then this one and this one, so another 2 escape, and then we have this 2 left inside. So that would make the square root of 32 4 rad 2. Simplifies to 4 rad 2. Because again, 2 times 2 is 4, and then we have the rad 2. And then to get this x by itself, we're going to subtract 4. Now, because these are not like terms, we can't subtract them. This one has a radical, and this one doesn't. So we're just going to bring it down. We could put the negative 4 in front, or we could put it after like we did here. So we can write our answer like this. Or we can write our answer like this. So our solution is negative 4 plus 4 times square root of 2. And then negative 4 minus 4 times the square root of 2. So this is going to be an irrational answer. That's why this was not factorable here. So now let's do it again. We know what the answer is. Let's do it again and get that same solution using the quadratic formula. So with the quadratic formula, the equation has to equal 0, which it does. And then a is the coefficient of the x squared. So since there is no number here, we know that there is a 1. And then b is the number in front of the term with the exponent of 1, so 8. And then c is the constant. Okay, so now we have our quadratic formula, and we're going to plug in those values. So go ahead and do that. Okay, so now we're going to simplify the quadratic formula. So order of operations, we do the inside of the radical first, so exponents first. So 8 times 8 is 64. And then this part right here, this is going to be a negative 4. So when I enter it in my calculator, I'm doing negative 4 times positive 1 times negative 16. So this negative, I'm not going to bring it down here necessarily. It's already being taken up with this negative 4 right here. So when I click equals, it's a positive 64. Okay, then we have 2 times 1 is 2. And now we're going to add 64 plus 64, which is 128. Okay, now this here is not the answer we got here because it's not simplified. So we know that this is not, we're not done because we didn't get the same answer as the completing the square. It doesn't look the same, but this will simplify to the same thing. So when we're done with simplifying the quadratic formula, the next thing we do is simplify the radical. We do not, this is like the #1 mistake I see on students' tests. We do not simplify this 8 and this negative 8 and 2. You cannot do that until the radical is simplified, and then there has to be a number that goes into this number here, and this number. So we have to do this first. Very important. So go ahead and simplify the square root of 128. I know most people like the factor tree method, so I'm going to go ahead and do that. So pick two numbers that multiply to make 128. So I know 4 goes into 128 because the last two digits, 28, 4 goes into 28. That's the clue that 4 would be good to use. So I'm going to keep doing this until they are prime factors. All right, got lots of 2's there. Okay, so now to simplify the square root of 128, I'm looking for partners, groups of 2, but only one makes it out of the radical jail. And then this 2 is left all inside. So 2 times 2 times 2, that's 8. So I'm going to remove the square root of 128 and replace it with what it simplifies to, 8 rad 2. Okay, so again, this does not look like what we got here because it's not done being simplified. So again, once we've simplified the radical, the next thing we do is we ask ourselves, does anything go into 8, negative 8, this 8, and this 2? Something that goes into 8, 8, and 2, which is 2. Now we're ignoring that radical there. So negative 8 divided by 2 is negative 4. 8 divided by 2 is 4. 2 divided by 2 is 1. Well, when we divide by 1, we just get the same thing back. So our final answer, we do get the exact same answer that we got over here. So again, some problems have 3 different ways to solve it algebraically, whereas this problem here only had 2 because it's not factorable. Whenever you get an answer that has a radical or imaginary number in the solution, it's not factorable. So you definitely want to know all the different methods, but on the test in this class, you're allowed to use whichever method you think is easier for you. So notice the directions said circle which method you would use. So on this problem, I'm looking at this method, and you know what? I usually, personally, this is just me, if it's not factorable, I always my go-to is the quadratic formula. But again, it's a matter of opinion whether you think this was easier or the quadratic formula, because you have to have the quadratic formula memorized in order to use it.